Hello everyone and welcome to the module about optimizations in Python. Okay, specifically we're dealing with linear programming. So like always, the source code is there, the website with the source code and explanations are always posted there for you to see. So let's begin. So as I mentioned to you the first time that we had these series, there's lots of libraries to use in Python, simply because that's the beauty of Python, is the fact that so many people have invested so many libraries into Python. So the hard thing is to figure out which library to use. There are many libraries that accomplish the same thing, but they have different syntax, different algorithms, and so on. So it's sometimes difficult to figure out which one is the best one to choose. I suggest that before you pick a library, that you do a small search and figure out which one's the most popular. Okay, or usually the most popular one's the best one. So in this course today, I'm going to be teaching you three types of optimizations. One using scipy, which I found on the internet and it appears to be quite common. The other one is mosec, suggested by Jesse, and the other is pyomo, suggested by Abdel. So we're going to go through all three. They're all very similar. Like I mentioned to you, it's just a library, okay? And whenever I use libraries, I always get intimidated because there's so many variables to think of. You have to do it a certain way and so on. So a way to get over that hesitation, that pain feeling, is to really read through the tutorials. Go through the tutorials line by line, just like how I'm doing here, and make sure you understand it, okay? These tutorials were built in such a way that it's a good place to jump off from, okay? After you learn these tutorials, the next level is the manuals, right? To get more details of how things work. But yeah, so the other thing that you can do as well is sometimes you can Google, and lots of people also have similar problems as you as well. So let's start with scipy. Okay, so scipy is a special library, so we want to import scipy.optimize and import it with the alias of linear programming, line prog, okay? So here we have a linear programming problem, okay? However, scipy has to be very specific. They can only do minimizations, and here can only be less than or equal to. Cannot be anything else. Okay. And also, I think xy has to be greater than equal to 0. So it's very straightforward. These are the things that you need to program. You need to put these values into the right places. So first we create an ABG, which is objective function. We have a -1, -2, so -1x, -2y. We have the left-hand inequalities, okay, so we have 2, 1, -4, 5, and 1, -2. Okay, right-hand inequalities are 20, 10, and 2, right there. And then we have left-hand equals. So this is -1, 5 equals to 15. And right-hand equals is 15. Then we set the bounds. So the first x bound is from 0 to infinity. And it's a float. And the second y bound is from 0 to infinity. Okay, so let's run that. Okay. Now what we have to do is we have to call this function linprog. And what happens here is that the objective function is set. The left-hand side inequality is set, right-hand side inequality is set, left-hand side equality, right-hand side equality, bounds are set, and the method used is revised simplex. So let's run that. And there we go, we get the results here. Here, x array, so actually what this is that the x value has this value here, and the y value has this value here. At this point, it is when we have the minimum. Okay. Also, we can take the opt.fun to get fund. Here's the is the objective function value at the optimum. Let's run that. Okay, so the objective function has this value at the optimum. Success, was the optimum found? True. X, what is the results? X is 7.7, Y is 4.5. Okay, that's it. So stay tuned. We're going to cover mosec in the next example.